Good morning, everyone. Today we are going to start the new heading that is called Fourier transform. This is one of the heading in um, integral transforms. As you know that we have done Laplace transform and Fourier series. Fourier series extension part is Fourier transform is there. Same formulas whatever we have used in Fourier series, little bit integration will get little bit different over here. Now you can see what it is. Yeah, I have to go for this infinite Fourier transform definition. Infinite Fourier or Fourier transform. Here you don't get confused by seeing two names. One name is infinite Fourier transform, I am saying, another name is just Fourier transform of a real valid function f of x is defined by see f of x is a real valid function. When you apply a Fourier transform on this, you will get integral minus infinity to plus infinity f of x e to the power I u x dx, right? In many books they have referred e to the power minus I u x. It is right, so don't worry about it. It is e to the power I u x, right? Provided the integral should exist and we obtain the function whatever after doing the integration, whatever the answer we will get in terms of u only. Usually we denote that answer by f of u, right? Now inverse Fourier transform. The inverse Fourier transform is nothing but f of u. I think you can connect this one with Laplace transform, where we are telling L of f of t is equal to f bar of s. I'm used there. Now the same thing I'm doing here. The inverse, if you want to take the inverse, you have to take the answer of this whatever say Laplace Fourier transform. Fourier answer is f of u. Now you are going to apply inverse on it. You will get this one as 1 by 2 pi minus infinity to plus infinity f of x e to the power minus I u x du, right? There with respect to x is there, here with respect to u. Please observe this change. In Fourier transform you will get integration with respect to x, here integration with respect to u, right? That is f of x is equal to f bar of inverse f of u, right? Okay, the same thing I'm writing. F of x is equal to 1 by 2 pi integral minus infinity to plus infinity e to the power minus iu dx du, right? Now infinite Fourier cosine and sine transform and inverse Fourier cosine and sine transform. Another two definition I'm going to introduce. The two definition is, one is Fourier sine transform, Fourier cosine transform, and inverse of cosine and inverse of sine transform. Here FC denotes the Fourier cosine transform. You just see it is limit of the integration is, earlier it is minus infinity to plus infinity, but it will moving on right side of the x-axis, that is 0 to infinity. F of x cos u x dx is called Fourier cosine transform and it is denoted by fc of u, right? Next, inverse I'm talking about. Inverse, if you want to get f of x is equal to 2 by pi 0 to infinity fc of u cos u dx du, this is called inverse Fourier cosine transform, right? Now sine Fourier transform, what is that? F of s, f of x is equal to integral 0 to infinity f of x sine ux dx, right? Please observe this one clearly. So it is so confusing if you see once. Therefore you remember what I am doing or what I wrote over here. This is called Fourier sine transform and it is denoted by fs of u, f of x is equal to 2 by pi 0 to infinity fs of u sine u du. This is called inverse Fourier sine transform. Now we will see some of the example of cosine and sine. Find cosine transform, cosine Fourier transform of 2 e to the power 5x. We know that formula is given by, what is the formula? Yeah, fc of f of x is equal to integral 0 to infinity f of x cos ux dx. So f of x is given to us as 2 e to the power minus 5x. So when you try to get this f of x, just let me write integral 0 to infinity 2 e to the power minus 5x cos ux dx is there. Now when you apply the integration, it is an you cannot go for integration by part, you have to go for a known result. What is known result? E to the power minus 5x divided by 5 square. 5 square means 25 plus u square minus 5 cos ux plus u sin ux. Now apply the integration value, upper limit and lower limit. When you apply e to the power minus infinity, it will get as 0. Only the lower limit will play give some result for it. Yeah, first one is 0. Why? Because e to the power minus infinity will get as 0. So second one I'm talking about, that lower limit. When you place x value as 0 over here, you see minus 1 by 25 plus u square minus 5 cos 0 plus sin 0 will be 0. Okay, so cos 0 will be 1. So minus 5 minus minus will get cancelled. We will get the answer as 5 into 2, 10. 10 divided by 25 plus u square. Similarly, I will try to get what it is the cosine transform. Yeah, here you can see this formula. Fs of f of x is equal to integral 0 to infinity f of x sine ux dx. In the place of f of x, I will place 2 into e to the power minus 5x sine ux dx. Now the known result I am taking e to the power minus x divided by 25 plus u square minus 5 into sine ux minus u cos nx, cos ux. So once again, if you apply the limit over here, yeah, limit over here, first one will contribute 0 upper limit, lower limit it is going to contribute over here minus 1 by 25 plus u square minus 5 sine 0 is equal minus u into cos 0. Sine 0 will be 0, so minus minus you will get plus, so 2u sine 25 plus u square it is. So I hope that whatever the things we are doing here, you got the actual thing. So thank you.